Hello everyone, happy to see you here. Welcome back to my channel Higher Mathematics. Today we have a very interesting cubic equation k cube plus k square equal to 36. We need to solve this equation for k, so if you have your solution, your assumption, you can also write it in the comments below and then we will check our answer, so it will be really interesting. Okay, so first of all, let's write the 36 on the left side. Okay, let's do it. So first of all, we have k cubes of the same beginning, k cube plus k square minus 36 and equal to 0. Okay, this is our first step. What we're going to do next? Right here we have k cube, so we have cube and we have square. We have a thumb, yeah, we have k cube and k square. Right now, let's try to express the 36 as a thumb of a cube and a square. Of course, there are a lot of ways how can we do this. Of course, we can express this like 10 plus 26 or different, a lot of ways how can we express this. But the best way to do this is to express this as 27 plus 9. And a lot of students might be asking, why 27 plus 9? As I said before, we have cube and square. 27 can be written as 3 cube. Yeah, we have this cube, yeah. And 9 can be written as 3 square. 9 can be written as 3 square. So right now, let's express the 36 as 27 plus 9. Let's do it. So we have k cube plus k square minus, and in parentheses, we have 27 plus 9. 27 plus 9 equal to 0. Yeah, really great. Right now, let's open parentheses. So we have k cube plus k square minus 27 and minus 9 equal to 0. Of course, we can do this instantly. We can write it like that, but I want to do this step by step. Maybe a lot of students watch this video, yeah? So 27 can be written as 3 cube. Let's do it. So we have k cube plus k square minus 27 can be written as 3 cube, and 9 can be written as 3 square, so minus 3 square equal to 0. Right now, we have k cube, and we have 3 cube, we have k square, and we have 3 square, so that's why we split the 36, because right now we can easily group our cubes and our squares. So right now, let's start, for example, with the cubes. K cube minus 3 cube. This is our first parenthesis, so k cube minus 3 cube. This is our first parenthesis, and we have plus k square minus 3 square. This is our second parenthesis, so k square minus 3 square equal to 0. Really great. Right now we need to know, because if we look closely from different angle, we have two parentheses. This parenthesis, this have a difference of squares, a difference of cubes, sorry. This one, difference of squares. So right now let's remember this formula from a school program, yeah? First of all, let's remember about a cube minus b cube. This is our all-known formula, a cube minus b cube equal to a minus b, and times a square plus ab plus b square. So a square plus ab, and plus b square. Okay, really great. And right now the second formula, a square minus b square, difference of squares. A lot of students know this formula. So a square minus b square equal to a minus b, a plus b, a plus b. Okay, these are our formulas, and right now let's apply first formula right here, difference of cubes, and the second one, difference of squares. So right now let's start with that. First of all, difference of cubes. K minus 3, k square, plus 3k, and plus 9. This is our first expression. Then I think we have plus k minus 3, and k plus 3, equal to 0. Okay, really great. Right now, let's look at this expression from a different angle. We have k minus 3 right here and k minus 3 right here. So we can actually factor it as a common. So let's do it. Let's factor this k minus 3 as a common expression. Let's do it. So we have k minus 3, and in another parenthesis, we have this expression. So we have k square plus 3k and plus 9. Yeah, and in another parenthesis we have plus k plus 3, so plus k plus 3. But to be honest, we can actually get rid of this parenthesis because we have all the time positive signs, so we can actually get rid of this parenthesis. Yeah, as a result, what do we have? we have k minus 3 in the beginning, k minus 3 in the beginning, and in another parenthesis we have k squared plus 3k plus 9 plus k plus 3. So we have k squared, 3k plus k, so plus 4k, 9 plus 3, 12, so plus 12, equal to 0. So right now we factor our question. Yeah, we have first parenthesis, we have the second one. So right now let's try to think how can we solve this part. Because when we have a product of two parentheses, we can easily solve it without any problems, because a product of two parentheses equal to 0 when the first parenthesis is equal to 0. So k minus 3 is equal to 0, or the second parenthesis is equal to 0. So k squared plus 4k and plus 12 is equal to 0. Okay, really great. So we have two branches, and right now let's solve. Real quick, we can solve this part, k minus 3 equal to 0, because from here k first is equal to 3. So this is our first root, k first equal to 3. This is our real number root. Without any problems, we can easily solve it. What about second one? This is our quadratic equation, so without any problems we can solve it real quick. There are a lot of methods. How can we do this? I prefer basic one with method of coefficients. So a equal to 1, b equal to 4, and c equal to 12. Yeah, really great. Right now let's do this. Let's solve this question. First of all, let's find real quick the discriminant. So b squared minus 4ac. Let's find real quick discriminant. So b squared, 4 squared minus 4 times 1 times 12. Yeah. From here, our discriminant is equal to 16 minus 48. So our discriminant from here is negative. So we have minus 32. So our discriminant is negative. It means that in this branch, we will have two complex roots. Okay, two complex roots. Right now, let's solve it. We will have two complex roots. So k second and k third equal to minus b plus minus square root of discriminant and all over to a. And right now let's plug in, we know everything, let's plug in each of these elements into this spot. So we have minus b, we have minus 4 plus minus square root of discriminant square root of minus 32 all over 2 times a, 2 times 1. Okay, really great. Final step, let's simplify real quick our square root of minus 32. We can write it as, so let's do this from beginning, so minus 4 plus minus square root of minus 32. We can write it as 16 times 2 and times minus 1. And according to a square root property, we can actually split everything. We can write it as square root of 16 times square root of 2 and times square root of minus 1. And right now, from a different perspective, if you look at this question from a different perspective, square root of 16 equal to 4, square root of 2 equal to, square root of 2 we can simplify this, and square root of minus 1 equal to I. So this is our imaginary unit. So our final answer looks like that. Minus 4 plus minus 4 square root of 2 times I. All over 2, and it looks like this is our final answer, but we can do one more step. We can divide it by 2, so we can write it as minus 4 over 2 plus minus 4 square root of 2i over 2. And from here we have minus 2 plus minus 2 square root of 2 times I. So these are our two complex roots. So let's write our final answer. So this is our real part. If you're interested in this, this is our imaginary part. So let's write our final answer to this question. So our answer, let's do this on the right bottom angle. Our answer, so k first equal to 3, k second equal to minus 2 plus 2 square root of 2 times I, and k third equal to minus 2 square root of 2 times I. So these are our two complex roots. So these are our complex roots, and this is our one real number root. So one complex, one real, and two complex roots. And in the end, let's check real quick our root. Let's write it. Let's do this right here. So for example, check. So we have k cubed plus k squared equal to 36. Let's check it. So we have 3 cubed plus 3 squared equal to 36, and everything is great. 27 plus 9 equal to 36, so our root is great. 36 equal to 36. Yeah, really great. So this is our answer. This is our solution to this question. So our root is great. These are our two complex roots, and this is one real number root, which is absolutely correct. And few hints, few prompts, few tips from me. If you have 3 as the highest power, for example, k to the power 3, it means that you have 3 roots in total, okay, according to a fundamental theorem of algebra. So this is like a quick proof for you, because a lot of students might be thinking, maybe I will have like the 4th root right here. And exactly in this case, we have 3 and 3 roots in total. So this is like a quick proof, because for example, when you have k to the power 5, it means that you lost 2 roots. And if we have, for example, k to the power 6, it means that we have 6 roots in total, not 3. So it means something went wrong. So this is like a quick tip. So every time you have this type of equation, doesn't matter how many variables, how many powers, it means that you will have that amount of roots. Okay, if 3 roots in total, if 2 roots in total. And that's why, for example, when we have a quadratic equation right here, we have 2 roots, because 2 is the highest power, so 2, and it means 2 roots in total. In our equation, in our part, 2 complex root, but doesn't matter. This is like, it tells us the amount of roots. So this is my quick tip. Every time you have equation, you can instantly, if you sit in your exam, you can instantly find out how many roots you have in this question. So 3, it means 3 roots. 2, it means 2 roots, and that's why this is like a quick proof for everyone. Our root is great. You can also check this complex part, but it's not necessary. Every time you have this type of equation, every time you sit in your exam, you need to solve only, you need to check only this real root, and it's not necessary to check this complex part, because it's not a good way. You can easily check real number root. This is my solution to this question. I really hope you understand it. I really hope you learned something new. Once more, I want to show you this solution. So it's not a hard question. So if you have problems with it, you can also ask something in the comments below. You can also exchange information, because there are a lot of teachers here, a lot of students, and I think everyone will help you without any problems. But to be honest, this question is not that hard. All you need from here, you just need these 2 formulas, and of course basic algebra skills to add something, to evaluate something, to add, and of course to solve equation with the 2 branches of a product equal to 0. We have the first branch real number root, and the second branch complex root. So this is not a hard question, so don't be scared about it. If you still struggle with this type of questions, I have a lot of challenges on my YouTube channel, a lot of questions, a lot of different questions. So you can also watch my channel if you're interested in this. I have more than like 600 videos with different questions for everyone, for students, for teachers, Olympiad mathematics, school mathematics, higher mathematics sometimes. Yeah, so I really hope you find what you exactly need, and to practice, that part, because this question, this is like a school question with a few moments, with these formulas, and of course with the basic simplifications, with the basic stuff. Yeah, so thank you for your time. Have a great day. See you in the next videos. Also write your thoughts, write your response in the comments below. I want to say thank you for everything, for watching my videos, for supporting my channel. I really appreciate it. So wish all the best in life. Take care of yourself and have a great day. See you in the next videos.